Hello, everyone. How's everyone doing? Oh, great. I love the enthusiasm. We have a great group here. I'm really excited for this panel, and I think you all represent some really interesting conversational topics here. So how about you all just introduce yourself first and tell us a little bit about what you're doing and maybe actually what you're even interested in talking about during this period. The general theme is how personal agents will affect our lives. So yeah.
Hello, everyone. My name is Miguel. I'm co-founder and chief scientist at Nillion. And what we do at Nillion, we're building what we call the blind computer, which is a new type of decentralized infrastructure, actually, that is not a blockchain. It interconnects and it interfaces with blockchain, but it's not a blockchain. It allows developers essentially to develop applications that can store and compute on private information without revealing it even to us. And so the angle on AI, we're very strong on AI and we're very focused on that. The angle that I'm interested in covering today is that of privacy. Like those agents, if they're really good, they will learn a lot of information about ourselves, and we will be the context that they receive, and that they essentially would get to know us really, really well from the inside out. And so the question is, what happens to privacy? Like, what happens to all that information if those agents are not run on a decentralized infrastructure, number one, that is not controlled by a single company, and number two, is not published somewhere on a public blockchain, but rather kept privately. So that is kind of the main concern and main angle I would like to cover today.
Awesome. Privacy. I love it. All right.
Privacy again. So I think privacy is the key, especially in terms of like personal AI, right? I'm Regan. I'm the engineering head for PinAI. So at PinAI, we were trying to build a coordination layer for personal AI. So we have like three major components. One, we call it the personal data protocol, which is used to get a user's data from different sources, like Gmail, Facebook, on Twitter. And we would then have a decentralized network that would be able to get all this data and then compute the embeddings and features out of it, and then send this back to user's device. And then when the user is sending intent, so there will be the AI agents within our network that will be able to fulfill this request. So the first part is the personal data protocol. And then the second part, we call it the agent service protocol, in the sense that everybody who is building an AI agent will be able to plug into our ecosystem that provides the service to the whole network. And then we also have an intent matching protocol, in the sense that whenever enriched intent from the user is submitted and broadcasted to the blockchain, then this intent matching algorithm will be match the corresponding AI agent with the intent and then provide service to that user.
So intent-based AI and privacy and sort of some of the agentic framework as well. Okay.
Correct.
Okay, very interesting. Cool. And yeah?
Yeah, so I'm at the Ethereum Foundation, where my job description is a mix of form verification and AI, which means that in the short term, we have very practical tools when it comes to AI, and that's trying to make our lives easier when it comes to formally verifying large systems like ZKVMs and things like this. Obviously, in the long term, and if we're thinking about looking ahead to 2030, I'm personally very interested in figuring out not just privacy, which is, I think, completely essential, but also reliability. If we're going to a world where everyone this week is talking about 1 trillion AI agents on chain, and where we outsource tasks to agents, which are outsourcing tasks to agents, and you end up with a chain of 100 or 1,000 AI agents doing something really complicated and fuzzy. How do we make sure that this is actually reliable and that they're actually doing what we would like them to do without, you don't want to over-constrain them, because the point of AI agents is that if they're really good, they should also be kind of creative and find solutions to problems that you might not come up with. But at the same time, if you ask for something, you would like to make sure that the output that you get at the very end of it is kind of consistent with what you asked. And at the moment, I don't think we have any way of even well-defining, how to tackle that problem.
Got it. I actually think it's really interesting how sort of the censorship rules or the gating rules or how you limit AI how that is established. And actually, this is maybe I'll tack onto your topic here first. I'm actually really curious, what mechanism do we do to accomplish that? Do we do that in a decentralized way? Is that a person by person basis? Is that like what standard sort of sets that? And you mentioned this connects to creativity of the AI, things like that.
Yeah, I think another thing is obviously different people will have different standards. I don't think it would make sense to set some kind of global standard for what agents can or can't do. Censorship resistance to a large extent is quite important. I don't think anyone would be happy with agents that have some kind of central actor defining what they can or can't do. That would probably go against most things that people stand for. I think maybe especially in whatever the Web3, crypto, whatever you want to call it, community. So I think a lot of it really comes down to personalization and, if anything, being able to make sure that any agent that you use is aligned in some sense with yourself rather than some central party that might train the models that power the agent, because at the moment model training is restricted to only a few companies. It's insanely expensive to compute. Even smaller models, for the most part, a lot of the best smaller models are still Google, Meta, and so on. So there should be a big focus, I think, on figuring out personal alignment, fine-tuning on things that reflect, our wishes, our values, whatever else, and going from there, rather than trying to define kind of strict rules for everyone.
Got it. One thing I'm super curious, actually, you were mentioning that you guys aren't really a blockchain, and part of your privacy solution. Do you mind just explaining a little bit more on that? Yeah.
Sure. So you can think of this of Nillion and the blind computer as it is a decentralized network. So we have several nodes, and the users submit inputs for computation. So you may think in terms of, oh, this is like a smart contract, but the difference is that essentially this is powered by privacy-enhancing technologies along the lines of multi-party computation or fully homomorphic encryption, so that at no point does any of the nodes involved in the computation, for example, running an AI agent inference query, get access to the actual information. They compute blindly, and hence the word, the name blind computer. And what you get in the end is also a secured response, a private answer that you can then reveal to whomever you want according to your access model. So be it the user. You can also kind of connect that response to a blockchain, so you can submit that to a smart contract. It can be consumed by a smart contract. But the important thing is that the execution, the actual computation, doesn't take place in a public blockchain, so that the inputs from the user as well as the weights from the network can be both protected.
So privacy can be preserved. Okay.
Exactly.
And I think FHE and MPC is like really interesting. FHE is generally somewhat slow, and I think there's sort of like in the whole process of like decentralize the sequencers, right? Decentralized L2s and like a blockchain analogy. They sort of started off with training wheels, right? And so I'm curious, do like TEEs or anything like that work as sort of like a on-ramp? And I think you mentioned something that sounded like you were probably using TEEs to get users Gmail information, things like that. I think that's probably like the best way to do that right now. Curious to hear your thoughts on that, and then let's dive into the privacy stuff and some of the other topics.
Sure. Yeah. So definitely we are launching like a protocol or a network that we will not be the central entity that will be getting users' data and store in our centralized database, right? So that's not a right way to do that. But then what we want to do is that the user has the full data sovereignty, and how that happens is that we would have a network that will be able to help user to get the data from different data sources, and then do the computation, and then the weights and the embeddings will be then sent back to the users. So it will not be stored in any kind of a centralized cloud. Yeah. In that sense, the user has the full data sovereignty. The reason we were using the TE environment to do this is that for the service to get all the users' data, if it is not running in like a TE environment, then potentially like a data leak or anything could tap into it. So that would put another risk at the data privacy. And also, there was another interesting component that we were trying to build within our ecosystem is that when the agent is exchanging some information with your personal AI. So for example, if you try to kind of book like a flight ticket or like a hotel, you got some sensitive information you want to share with the agent, right? So maybe your name, your credit card information. So that would definitely want to be able to be exposed to the public. So we envision that to be kind of the information is exchanged in an enclave in the TE environment.
Okay, got it.
If I may double click on the TE side. So essentially it's another privacy enhancing technology. Our view is that there is no single PET that actually beats the rest of them. You were mentioning problems around FHE and performance. So we have on the one side the high security solutions like MPC and FHE. On the other side, weaker solutions in terms of security, but actually much more performant like TEs. The way we see it is that we should strive for a combination of the two. That depends on the user, desired trade-off point on the trade-off space. So that, for example, you can run maybe some layers on MPC or FHE, and then the rest of the layers, you can run them on a TE. And we're also doing a lot of work on accelerating those stronger, those technologies with stronger security. Like, for example, we've done work with Meta and with other universities to accelerate, and we've done it like 10 times, the inference of AI models on MPC in particular, and also on TFHE. So I think it's like a combination of them that will yield the best results for given use cases and given users.
Got it. Alex, so I'm really curious. You were mentioning something when we were talking before this panel about lots of agents running, maybe unchecked, doing crazy things, and in groups on a blockchain, all talking to each other. I'd love to hear like a little bit more about that, like what you were talking about. It's super interesting.
Yeah, so I think it's going back to kind of people talking about 1 trillion AI agents on chain, agent GDP being higher than human GDP, whatever else. But it's essentially the easier it gets to launch an agent, the more agents we'll have. And it's obviously much easier to launch an agent than to have a kid, so we can probably expect to have more agents than kids. And that means that at some point you might give a task to an agent, which then, gives part of that task to another agent, which gives part of that subtask to another agent. And you end up with a chain of a lot of agents doing something to complete your task. And this is something that people are demoing. We had a demo yesterday at another event from Nethermind that showed, kind of one agent finding another agent to do another task to complete the original task. And I think if you have one agent, it's quite okay to kind of have a look at what is done and figure out if that's what you wanted. If you have a long chain of 100 agents, 1,000 agents, 100,000 agents, you obviously start to lose any kind of sense of being able to look at what they're doing and make sense of it, because it's also obviously something that's supposed to go quickly. You probably don't expect to wait, hours or days or however long it would take you to look at what they're doing to get the output that you want. And once you train a lot of agents, and they all might be 99.9% reliable, maybe they're just 0.1% unreliable, but then when you have 1,000 agents who are all 0.1% unreliable, the probability that something starts to go wrong at some point in the chain becomes not negligible and becomes worth worrying about. And there's a very interesting thing then, which is, do you just live with it? And, how does that work? And especially for tasks that have some evaluation metric that's quite subjective. So if you want to order a pan off Amazon, and then you'll find out a few days later if a pan gets delivered to your house, it's pretty straightforward. If you want to say, tell me how to interpret this piece of news, it's much more complicated. There's no kind of ground truth interpretation or anything like how do you evaluate what you get? How do you evaluate if some agent anymore hasn't just like completely gone off the rails? And we've seen models go off the rails, like Claude went off the rails a few months back and started speaking Spanish or something. It might do that in the middle, and then you get some weird thing at the end. And so that's something that's I think not well defined as a problem. There certainly aren't solutions that are well defined either. But it's worth considering a lot of these kind of like small edge cases. The more and more we use agents to do interesting things and to do kind of maybe very valuable things that have a high risk of bad outcomes if there's some failure in the chain, the more those use cases become something to deal with, and for people who are building agents, actually dealing with those use cases might become the product. And so it'll be kind of interesting to think about how to tackle these issues.
Got it, got it. Yeah, I guess one thing on the privacy side we were talking about as well, there's sort of like, you'd mentioned maybe two reasons. So one is we obviously don't want to give up our data, right, to other entities. That's really important. But the other side is we probably don't want, you know, some of these companies to collectively manipulate the masses, right? So I'd love to just, yeah, if you guys want to dive into that, that'd be interesting.
Yeah, absolutely. I think this is one of the major risks. We're used to the risk in Web 2 of companies selling our data behind our backs. That's nothing compared to what you're talking about, Will. I think there's a much more concerning problem here, which is that AI on personal agents will know us to such an extent that they will be able to know what are our cognitive biases, our blind spots, and they may utilize that to control us and manipulate us in ways that we wouldn't even, notice. And, that has a tremendous amount of potential risk for us. It's been never heard of a company, a single central power having that much control over us. So I think that's a very concerning scenario and a very good reason to, number one, decentralize this so that it's not just a single company, but number two, to not even share that information with them. And for that, privacy becomes essential.
Got it.
Yeah, so actually, from my perspective, I think it's a balance. That, for example, right now, if you go to like Amazon or Google, they know a lot about you. So actually, they provide some good user experience for you. But sometimes you just feel, hey, my privacy is kind of broken. Yeah. But I think it's like a trade-off. But definitely, I think there are some like red lines there that we shouldn't be crossing. Yeah. So. Yeah, so that is from my perspective.
Yeah, I think there's a mix of things. I think to some extent, the misinformation angle isn't particularly well defined, I think. Like it's you already have a ton of people who just spew things that are wrong. And that's kind of something we've just learned to deal with as a society, or not deal with, I guess, depending on how you feel about the current state of things. I don't think, a bunch of AI agents kind of pushing things that are blatantly false is too big a problem, or at least more than a problem than misinformation already is now. In the same way that I think there was a big worry about misinformation when GPT-3 and GPT-4 came out, and it's turned out to not be a big issue. We're not, inundated with deep fakes of everything and whatnot. The problem with misinformation is typically to get people to buy it, not to produce it. And so far, the kind of production is simplified, but that's not the actual issue. The people who want to push misinformation will not fall, but then on privacy, like I completely agree, and I'm very much in favor of smaller models that run locally, if not only for privacy, but also just for reliability, so that once you've downloaded a model, you know that it's there and that it won't be tampered with. I think otherwise, the possibility that everyone uses, the same model on the same cloud infrastructure, and that gets, changed in some way or another, and without people noticing, and that changes the outputs that people get that they would expect, and they can't really know what's going on because it's completely not transparent what model you're interacting with. I think that's also quite important, and kind of hopefully we either figure out better guarantees on the cloud side, or we figure out much better performance and UX on the kind of local side, so that we can run local models for kind of maybe medical applications that are very sensitive to privacy and so on.
Just want to add one more point. So actually, your data, everybody's data, could be monetized. But right now, we are actually not getting anything back. So I think the system is kind of somewhat broken. So your data could be monetized, and your intention could be monetized as well.
Got it. All right, I think that wraps up our time. As a goodbye, maybe, what's your favorite model version that you use in your day-to-day life right now?
For privacy preserving purposes, Llama 7B is a very good one. 70B is also very interesting.
I use like ChatGPT, Perplexity, and also like for on-device model, we have our own model trained on device. It's a 2.5 billion model that is used to kind of generate the function call for day-to-day tasks.
I guess on the cloud, Claude's 2.5 Sonnet, same as many people, and then I don't have Apple hardware because I run Linux, so on my laptop I'm probably constrained to Llama's 2.2, 8B or 11B at best.
Awesome. Thanks all. Great.